Again, good morning. For our next topic, we are to discuss normal distribution. However, before we go to the topic of normal distribution, let us go back first to your written output number 2, wherein you were given 3 problems and you were expected to show the solution or send the solution to me. Okay, for number 1, you were given the table wherein X is the number of patients seen in the ER. So, X is the number of patients, or a random variable represents the number of patients seen in the ER in any given R. The probability distribution contains the random variable and its probability. So to solve for the expected value, all we needed to do was multiply. We get the sum of the product of the random variable with its probability, and then we now have the value of 11.3. So the final answer will be 11. The expected number of patients is therefore 11 every R. We need to round off 11.3 to 11 because we're referring to the number of patients. Second, in a clinical study, in one group of 12 people in the same age bracket, 7 have 1 tattoo, 3 have 2 tattoos, and the rest have 3 tattoos. If a person is randomly selected from this group and evaluated for depression, what is the expected number of tattoos that the person will have? Looking at the question, what is the expected number of tattoos that the person will have? Therefore, our random variable should be the number of tattoos that the person have. From the problem, we know that there were 7 having 1 tattoo, 3 have 2 tattoos, and the rest, which is equal to 2, have 3 tattoos. So to get the probability, all we need to do is we now divide the number of people having 1 tattoo with the total number. But since it is given in the problem that 12 people were surveyed, therefore the probability that the person have 1 tattoo is 7 over 12, which is 0.58. The number of people having 2 tattoos is 3. So to get the probability, we'll now divide 3 by the total number, which is 12, which is also equal to 0.25. And people having 3 tattoos is 2. How do we know it's 2? Because there were 12 people surveyed. 7 have 1, 3 have 2 tattoos, so 3 and 7 makes 10. If there were only 12 people surveyed, then the rest would be referring to 2 people having 3 tattoos. So 2 divided by 12 will give me 0.17. To get expected value again, we multiply the random variable with its probability and then add everything. This will give me 1.59, which is approximately 2 tattoos. Number 3, we're given the random variable, which is 1, 2, 3, 4, and 5. And you were given the respective probabilities as 0.15, 0.27, 0.21, 0.25, and 0.12. The next column refers to the product of the random variable and its probability. So we now multiply the variable x with the probability 0.55, giving me 0.15. We multiply the random variable 2 with its probability of 0.27, we get 0.54. We multiply 3 by its probability of 0.21, we get 0.63. 4 by 0.25, we get 1. And 5 by 0.12, we get 0.6. We add everything up. We get 2.92. 2.92 now refers to the mean or the expected value. So our mean is now 2.92. In the next column, we subtract the mean from the random variable. So 1 minus 2.92 is negative 1.92. And then we square negative 1.92 square becomes 3.6864. And we multiply this with the probability of 0.15, giving me 0.553. Again, in this column, the random variable 2 is multiplied at 2. We will subtract from 2 the mean, which is 2.92, giving me negative 0.92. We square negative 0.92, giving me 0.8464. This 0.8464 is now multiplied with its probability 0.27, giving me 0.229, and so on. After getting the product of this, then we add everything up, we get 1.5594. 1.594 is now our variance. And to get the standard deviation, we only get the square root of the variance, which is 1.26. Therefore, our mean is 2.92, our variance is 1.594, and our standard deviation is 1.26. Okay. So we go now to our next lesson, the normal distribution. For added information, the normal distribution is a very powerful tool in statistics because it allows us to make inferences or conclusion from evidences about the whole population based on the characteristic of a sample. So, we now make a conclusion based from the data that we make a conclusion for the population based on the data we have gathered from the samples. And the number of collected measures become larger, the class becomes narrower, and the frequency histogram appears more like the smooth normal curve. So, it now illustrates a curve which is a good representation of a data set that is normally distributed, or the data are now normally distributed within all the numbers given. This is what we call the normal distribution, also known as the Gaussian distribution. The information we gather will determine the skewness of the curve, and skewness is defined as the measure of symmetry or asymmetry of the probability distribution of a random variable. So these are examples of a curve. Now, if the mean, we look at the left graph, if the mean is less than, the mean is here. If the mean is less than the median, the distribution is concentrated on the right side. So there are more data here, and the left tail is longer. We call this negatively skewed distribution. However, when the mean is greater than the median, the distribution is concentrated on the left side of the graph, and the right tail is longer, then this is what we call positively skewed distribution. So this is example of the normal distribution. Notice that in the middle, we have 0. And on the right, we have 1, 2, and 3. Again, from 0 going to the left, we have negative 1, we have negative 2, and we have negative 3. So what does this mean? The line in the middle of the curve is now what we call our mean. This line in the middle of the curve is our mean. And from 0 to 1 is a 1 standard deviation. So if we're going to look at this graph, we're going to notice that our mean is 0, is placed here in 0, and our standard deviation is equivalent to 1. So what does it mean? It's only 1 standard deviation away from the mean. So the normal distribution is determined by 2 parameters. We will determine a normal distribution by two parameters. One, the mean, which is in the middle of the curve, and the standard deviation. From 0 to 1 is 1 standard deviation. From 0 to -1 is again 1 standard deviation below the mean. So the standard normal distribution is a normal distribution with a standard distribution of 1 and a mean of 0. So the areas under the curve can be found using the areas under the standard normal curve table, or better known as the z-table. So this is our mean. Mean is at 0, 1 standard deviation, 1 standard deviation. From the mean, this is 1 standard deviation. This is 2 standard deviation. This is 3 standard deviation. From the mean, this is 1 standard deviation below the mean. This is 2 standard deviation below the mean, and that would be 3 standard deviation below the mean. Okay, so what are the properties? First, as we can see, the distribution is bell-shaped, always bell-shaped. Second, the graph is symmetrical about a vertical line to the center of the curve. So if we're going back again to our distribution, you're going to notice that our normal curve is symmetrical. So this line, the mean, divides the curve into 2 equal parts. So the mean, median, and mode coincide at the center. So the line in the middle of the center refers to the mean, median, and mode. And the width of the curve is determined by the standard deviation of the distribution. So the larger the standard deviation is, then the width will be longer. The tails of the normal curve flatten out indefinitely along the horizontal axis, always approaching the axis but never touching it. The asymptotic to the horizontal axis, which means that the values move away from the mean. The curve gets closer to the horizontal but will never meet. Let's go back to our curve. You see that our curve is symmetrical. This is our mean, median, and mode. From here, from the mean, the values goes away from the mean. It is going horizontal. However, as you notice, this horizontal line is the asymptote of the curve, which means that the curve is approaching the horizontal line. However, it is not touching. And the last property is the whole of the curve. The whole value, the area of the whole curve is equal to 1, which makes it, since it is equal to 1, it makes it the probability. The areas can now be referred to as the probability. Okay. So, the mean at 0, 1 standard deviation. Okay, the areas under the normal curve is known as the z-table. Z-score is a measure of the relative standing, or we say that if this is our normal distribution, if this is our normal distribution, our mean is at 0. This one is 1 standard deviation away from the mean. This is 2 standard deviation away from the mean. That is our z-score. Whatever the z-score is, it only refers to the number of standard deviation away from the mean if it were positive. But if it were negative, like -1, this is -1 is 1 standard away below the mean. 1 is 1 standard deviation away from the mean. -1 is 1 standard deviation below the mean. Okay, so let's look at how we can make our z-scores. So to calculate, we simply subtract mean from the measurement and divide the standard deviation. Okay, we will go to that later. The final result is final result is the C-score, which represents the distance between a given measurement x and the mean expressed in standard deviation. So either the C-score locates x within a sample or within a population. So how do we get the areas that corresponds to a z-value? Okay, first, we express the given z-value into 3-digit form. Second, we use the z-table and find the first 2 digits in the left column and match third with the approximate column on the right, and then read the probability or the intersection of the row and the column. This is our required area. Okay, let's get one example. We are to find the area that corresponds to z equal to 1. The z-score is equal to 1. We now express 1 in 3 digits, so it's going to be 1.00. From the table on the row, we look for 1.0. And then on the column on the right, we look for 00. The intersection of the row and the column will now give me the area or the value for the z-score, which in this case is 0.8413. This is now our required area. So this is an example of our z-table. So 1 would be there. 1 is there. Please look at the last. 1.0 is there. On the second column, we have 0.00. So the area wherein the row and the column meets is now the area that we are looking for. Okay, next example. We have the z-values as 1.36. So first, we look for 1.3 in our rows. One, 1.3 in our rows. It's there, 1.3. And then we now look for the column of 0.06. The area where the column and the row meet is now what the area that we are looking for. The area or the probability that we are looking for. Okay. Let's go back to our area that corresponds. That is how we're going to get the value or the required area. However, the area that we're looking for is expressed in this graph. Okay, so that is z equal to 1. For number 2, where z is equal to 1.36, we now have the value of 0.9131. We are now looking for the area from the left until 1.36. Okay, please practice reading. For our third example, we're looking for z equal to negative 1.58. So we will be using the C table wherein we have the negative values of our C score. So this is it. So negative 1.58 in the column, no, rather in the row, we look for negative 1.5. Here, negative 1.5. But we're looking for negative 1.58. So negative 1.5, we are going to look for 8.08. So we get 0.571. 0.0571. This is now our required area. And our graph is shown this way. For number 4, fourth example, we are to find the area that corresponds to the right of z equal to 2.08. So we now know how to get the area for 2.08. In the rows, we look for 2.0. And then moving to the right, we look for the column which will be equal to 0.08. The intersection of the column 2.0, rather the intersection of the row 2.0 and the column 0.08 will be the area that we are looking for, which will give me 0.9812. However, we are looking for the area to the right. So in our graph, you are going to notice this one. .9812 is the area from the left until 2.08. But we are looking for the right, the area that corresponds to the right. So from our earlier discussion, we note that the area of the whole curve is equal to 1. So we now subtract 0.9812 from 1, giving us 0.0188. This is now the required area. Okay, again, when do we subtract from 1? What is 1? 1 is the area of the whole curve. And we are subtracting the area that we got from 1 because we are looking for the area that corresponds to the right. 0.9812 corresponds to the area from the left until 2.08. To get the area to the right of 2.08, we now subtract it from 1, so we get 0.0188. Okay, next we are to find the area between 0 and 1.6. So our graph looks like this. This is our 0 or our mean. From 0, between 0 to 1.6. So we're looking for this area. So first, we look for the area from the left to 0, which is equal to 0.500. So this is 0.5, half of the curve is 0.5. Now, we get now the area of the z-score 1.6. Looking at the table, we have the area of 1.6 as 0.9452. But you are asked for the area between. So to get this, from 1.6, we subtract the 0. The area of 1.6 is 0.9452. We subtract the area of z equal to 0, which is 0.5. So it will now be 0.9452 minus 0.5 will give me 0.4452. So we're looking for the area between 0 and z-score 0 and 1.6. But we're also asked for the probability. The probability may now be expressed in the form of percentage. So the area is 0.4452. And to get the probability, all we need to do is change it to percentage, change it to percent, giving me 44.52%. So the probability is 44.52. And the area is 0.4452. So again, in number 6, you are to find the area between 0 negative, the z-score 0, negative 0.14, and z 2.59. So our graph would look like this. This is negative 0.14, and this is positive 2.59 z-scores. We're looking for the area in between. So from our table, 2.59 is 0.9951. Negative 0.14 is 0.4443. But we're looking for this. So we now subtract the area of 2.59. We subtract the area of negative 0.14 from the area of the z-score 2.59. Therefore, 0.9951 minus 0.443 is equal to 0.558. The area is therefore 0.5508, or the probability is equal to 55.08%. Okay. So again, we will repeat. We will just summarize what we have discussed in getting the area. In getting the area of the z-score, first we have to change it into 3 digits. So looking at 2.59, in the row, there are 2 tables. One is negative and the other is positive. If I were looking for the area of 2.59, I will use the positive table. In the row, I will look for 2.5, and then going to the right, looking at the column, I will look for the column 0.09. The intersection of the row 2.5 and the column 0.09 will now be the area that I need. If the value is a negative 1, then I use the negative table. So in this case, it's negative 0.14. So in the negative table, I will look for the row negative 0.1. Going to the right, I will look at the column which is 0.04. The intersection of the row negative 0.1 and the column 0.04 will be the area that I am looking for. And this area can also be changed into probability by changing it into a percent. We can now have our third written output. So again, you use the C table to determine the following and show the graph that we are referring to. Again, I will be waiting for your answers through my webmail, victa.carmencita@ess.edu.ph. Good luck, guys.